So we're looking at continuous distributions. So how do we find the two big ones, the expected value and the variance? I mean, they're the two pieces of data we really want to find. So x is representing our continuous random variable, and here's our formula. Because now we're talking about continuous, so we no longer say the sum of xpx, it now becomes an integral. So we're summing up all those rectangles, if you like. So going minus infinity to infinity, again, it's x times, but not probability x this time, it's the function x. Remember, the height of the probability distribution function was like the probability. So it's very similar to the xpx. Note, still true. Expected value will still be the mean of the distribution. So let's say this is our probability distribution for, what are we doing? So this one's a salary. So proposed to model the quarterly salary measured in thousands of dollars to salespeople. And we're only interested with x greater than or equal to 16. So we're going to look at the median and the mean, and from there just give a bit of a description of the salaries. So the median, remember that would be the integral from minus infinity to m, but our one doesn't start until 16, so I'll do the integral from 16 to m. 2,560, common factor, I'll take that to the front of the integral. So really we're just integrating x to the minus 7 on 2. Add 1 to the power over the power, and we end up with minus 1,024, x to the minus 5 on 2. Sub in the m, sub in the 16, rearrange it all, make m the subject, and we end up with 21.112. So the median salary, that was in thousands of dollars, so we get $21,112. So there's our median. Mean, we'll now use our new formula. So it'll be 16 to infinity this time, of x times x to the minus 7 on 2, which is, of course, x to the power of minus 5 on 2. Add 1 to the power over the power. Now, again, I've put infinity there, but remember, we don't really substitute infinity. We look at the limit as x approaches infinity of x to the minus 3 on 2. That limit would be 0. So that being the case, I could think of it as, well, when I substitute in infinity, I'd get 0. So therefore, it's just minus 5120 over 3 times, well, it'll be negative because it'll be minus when we substitute in the 16. So minus 1 on 64, we get 26.667. So the mean, again, we're talking thousands of dollars, 26,667. So what does that tell us about the distribution? It tells me the median is less than the mean. So the median, so half of the data is on the left-hand side of the mean. So that's what we call positive skew. You recall that one from, what year did you do that? Year 10, year 9 or something like that? So positive skew. Now variance, how do we find that? Well, again, it's going to be exactly the same. Expected value of x squared minus mu squared. So expected value of x squared then would be x squared times function x. Just like when we did it with discrete ones, it was x squared times probability of x. Same sort of idea. So let's find the standard deviation. So again, pull out the 2,560. It'll be x squared times x to the minus 7 on 2, but then minus the mean squared, which we just found out was 80 on 3. And so we get x to the minus 3 on 2, add 1 to the power over the power. Again, when we find the limit as x approaches infinity, that'll also go to 0 again for the x to the minus a half. So we end up with, after all that calculation, 568.889. That's the variance. They've asked for the standard deviation. So the square root of that, 23.851. So standard deviation, 23,851. When you think about it, that's quite a large standard deviation. Now what you'll find is that the smaller the standard deviation, the more clustered the data is around the average. So this is telling me that because it's quite a large one, then it's not going to be so clustered around the average. It's going to be quite spread out. There's the actual graph. All right, it starts off, but of course it keeps going. Do you remember what the formula was? It was x to the, minus 5 on 2, was it? But it's going to keep going. So that data is very spread out. So there's the position of the mean, there's our median. So there's the positive skew we can see in the distribution, what actually happens there. Okay, so 16C.